All right, so hyperbolas look a little bit crazy, but they aren't that different from ellipse. They are different enough that you're going to want to make a choice of which one you work on at one point. So don't switch between 8.3 and 8.4 because it gets confusing. A hyperbola comes from two cones that are on top of each other, and if you slice so that it cuts off just the edge of each of them, it makes this U shape on both of them. Notice how they're facing opposite directions because of that. Because it's kind of like the top of the first cone and the bottom of the second cone. And this can go sideways too. So either it's going to be like a U going up and down like this one. That's called vertical. Or ones that go side to side like these. Those are called horizontal. And I'll tell you how to tell the difference between them in just a second. Kind of. But in the equation, how to know from the equation. So the center is still HK. It is still the middle of anything. So if you have the foci, find the middle, that's the center. If you have the vertices, find the middle, that's the center. There's no trick to the center, it's the middle of anything. Okay? There will be some asymptotes today. We've seen these last unit. They are these dashed lines in the middle that they don't cross, but it just gets really, really close to this one and this one. Their only job is to guide the curve. They're kind of like border lines. I said guide the lines, guide the curve, slash curve, same thing. And they are always going to be diagonal today. Not up or down, not side to side, diagonal. And we will draw them through that box in the middle. Basically, the vertices and the co-vertices are these 4 points right here. And you draw a box through them, like that. Some of you even asked if we could do that on circles. I think Tyler asked it that day because the circles were going pretty rough there for a while. When you draw the lines through them, that's what makes the curves. Okay? The vertices are A units away from the center, and they are what's called turning points. The reason why I'm pointing that out is because you'll realize that there's not a curve on all 4 of them. There's only a curve on either these 2 or these 2. These 2 points don't really get used. They're not part of the actual graph. So the co-vertices are just there to help you draw the box, and that's it. And they are B units away. Foci are always C units away. Vertices is A, co-vertices is B, foci are C. It's been that way since we did the ellipses. There is a formula to find C, except for it's slightly different. Instead of adding them or subtracting them, you add them together. So on that foci on this one, I subtracted the two denominators. Now we're going to have to add them together. And it's kind of because the foci are outside the curve. They're kind of like further away than the vertices instead of being closer than the vertices. That's those 2 right there. It sounds kind of confusing at first, but once you get the handle of ellipses, these become even easier. They use kind of the same rules. A couple of people said they liked them better. I don't personally, but I'm not saying that you can't agree with that person. Jake Lemon said that. I think he pretty much just says whatever is backwards of what would make sense to a normal person. So I'm going to start it the same way we started our other ones. You got your x minus h squared and your y minus k squared. In an ellipse, though, these 2 things are being added. Now they have to be subtracted instead. That is pretty much the only main difference between the way that these look. And then a squared and b squared go on the bottom. This time, though, a squared doesn't have to be the bigger one. A is just the first one. So A is always first. Some people like it better, some people hate it.
I can't see it.
Yeah, the computer's in his way. I know, I like moved all my stuff. Too
so
close. Gotta get back. I'm gonna write the vertical one too. The only thing that changes is x and y switch spots. If x goes first in the equation, it is horizontal. If y goes first, it's vertical. So same equation essentially, we're just putting y first instead of x first. And as we go to draw it, now that we have both of the equations up there, it's honestly not going to be as difficult. The foci are always going to be the tricky part of all of them because that's where you start getting some random decimals and they're less friendly to work with. A couple of notes. I already said this once, but now that we kind of see everything, the line does not actually go through the co-vertices. You just use the co-vertices to draw the box for the asymptotes to go through. Okay? And it makes a little bit more sense once you see an actual example. So while I know that was a lot of information and it's probably a little bit all over the place right now, I'm going to go ahead and just start with this one. There's no numbers up here with x and y, so you have a center at 0, 0. We're going to go ahead and put that point right there in the middle at 0, 0. Then you have a 4 as the first denominator underneath x. That is going to be the vertices, because instead of just being the bigger number, a is always first. It's actually a little bit simpler to work with that way.
Teachers and students, I apologize for the interruption. I literally just got a phone call from Lansing. The JV girls softball game has been canceled. These following students will report to the inside cage for practice. You will not be released from class, and you're not going to the game. Tyler Harper, Bree Gable, Blythe Hewins, Lillian Cooper, Sarah Watts, Carrie Young, Tegan LaRoe, and Sego. Those students need to stay in class. Thank you.
Bummer.
No, I didn't want to carry on.
There.
She's not playing.
Shut up.
Okay, so I also wrote the points up there while Mrs. Kimberlin was talking. We went 2 away. This point is 2, 0. This point is negative 2, 0. Those are the vertices. The co-vertices have to do with the second denominator. Square root of 9 is 3. So we're going to use the y values, up 3, down 3. But instead of drawing an actual point, I'm going to draw a little x. And this is basically my trick to remembering which one gets the curve, because those are the ones I don't want to actually draw the curve through. And those points are up 3, so 0, 3, and 0, negative 3.
Venice.
And then I'm going to zoom in on my graph a little bit so that you can see it easier.
What is that?
Because now we don't really need the equation anymore.
Actually, these are English.
Okay. Draw a box through those 4 points. Not the center, but the other 4. It's technically supposed to be a dashed box, but like, whatever. It doesn't really matter.
What's the Charlie versus Blue? My leg hurts.
It's like cramped up and you can't move
I
it.
can't move it. What is the piece that we got that with the walls?
And then draw your asymptotes through the diagonals, like that. Those should be dashed lines. If you draw those as solid lines, it typically looks pretty confusing in just a second.
They have to be straight.
I mean, just do your best.
I mean, just like relative.
Yes, yes. And then you're going to draw a curve that gets really close to those sides, like this. Notice how it doesn't go into the middle of the box. It doesn't cross any of those diagonal lines that we just drew.
We can't see. Hold on,
I
your
know.
hand's lagging.
I know, my hand's lagging.
Oh, yeah. This is not too
Huh?
hard. It won't that bad.
No, it's really not. Before we do the foci, I know that's the part that nobody likes, we are going to write the equation of these two lines in y equals mx plus b form. Does that kind of ring a bell from Algebra 1-ish times?
Those past.
Okay, so this number,
I don't know, that was a long time ago.
this number is your slope, rise over run,
Yeah.
and this number is your y-intercept. The nice thing about this one is they both cross the y-axis at 0, so they'll both have plus 0 at the end. But we do have to count the slope. The good news is, that's slow today. You have the center and you have the edge of the box right here. So you just have to count up 3 over 2. So your slope is 3 over 2. X. And then give one of them a negative because the other one goes down 3 over 2.
The plus 0 again?
The y-intercept. They both cross the y-axis at 0. Other ones won't. I'll be honest that most people actually prefer it when it's a real number because zeros freak them out.
I like 0.
And then the last part is the foci. As I kind of set up here, you have to add the two numbers from the bottom together and do the square root of them. There it is. So this one will be the square root of 4 plus 9. Or 13. And the square root of 13 is 3.6. And that goes towards whichever one you just drew the curve through.
I just like one weird question for Einstein back there. What do you want to be when you grow up?
Computer stuff.
Makes sense.
I was like, why are you thinking about that?
Okay, so I go 3.6 in both directions.
It's blue.
I know. It happens sometimes.
Wait, no.
You like it blue?
No.
This is like, ew.
I mean, it matched your hair pretty good.
You know, I got called Smurf at the other day.
Like that.
I can't read
Not
that.
3.6.
Yes, 3.6.
Yes.
That's smart then.
Is that the one who called you Smurf at first?
No.
And then we're going to do the second one. I will tell you guys there is a backside to the notes that we are not going to do because I didn't put any of them like that on the assignment. It goes a little bit quicker the more times you've done it. This one is not at 0, 0. It's at -1,
Plus
3.
3.
Why did I have to put the -1 first?
Because that's fine.
The X one.
Yes, the x one has to go first.
No.
Did I first thing this morning say that it was at 3, -1? Yes, I did. It is not at 3, -1 because x has to go first. So then we put that left one up 3. Since y goes first this time in the equation, that means it's going to be an up or down one. What is the square root of 36?
6.
So we're going to go up 6 and down 6. And if you don't want to count out those squares,
Just guess.
it was at 3 before. What's 3 plus 6? 9. Just guess. And 3 minus 6 is -3.
You'll get there. You'll be close enough.
And then do the same thing, but for this one, The square root of 9 is 3. So you're going to go right 3 and left 3. And make your box. Draw the diagonals.
Why is words in Tyler? Just guess. I'm gonna put that in your book.
And then your diagonals. No, they don't have to be perfectly straight.
Yeah.
Oh, dude, I'm like,
That's what I just said. I'm gonna put that up in your book. What's the largest thing you've ever heard in school? Just guess. Okay, just guess.
I have to think of a good quote.
And then we're drawing the curve through these two. Not the other two, because those were the
I kind of want to see
second ones.
Nessa, how cool would that be? They're just like it's The Shining. Yeah, still.
Okay,
Be like murder.
let us finish real quick. These co-vertices are right 2 up 3, 2, 3, and the left 4 up 3, negative 4, 3.
What was your swimming pool?
That was 11 years ago. I have no
Did it make
idea.
something like unique, like something
No,
you remember? You just
no.
probably- I bet you were like one of those people like school was nice. Let me go back
We
to-
actually, I don't know if we did senior course.
That's sad.
Yeah,
That's interesting.
we had a class of 400 people though. So,
Mine's probably just gonna be, I don't know.
but I could look back and see. I will look back and see if I can find it for you.
I'm gonna spell stuff
Okay.
on the periodic table.
So for your asymptotes, y equals. We gotta finish the notes, and then you guys can talk while you finish your assignment. The slope goes from the center to the corner of the box. It's going up 6 over 3. You don't have to recount it if you want, because it's just these two things right here. The square root of 36 and the square root of 9. But what can I write instead of up 6 over 3?
Oh, 2.
Two.
It's just 2.
It's just too quick.
So 2x and negative 2x. Be nice. And then at the end, we have to put the y-intercept. Here's the thing. Sometimes, if you didn't draw your lines very well, it's hard to tell. Like, I can't really tell where this line is actually supposed to go through the y-axis. So I'm going to use that slope. If I go up 2 over 1, that's my y-intercept, which is up 5. Yes.
Oh my god.
And this one is at 1.
Hi, how can I help you? ¿Qué te pasa, calabaza? Didn't answer. You didn't know who it was? Yeah, I don't know who.
Okay, for the foci, square root of the two bottom parts added together. 36 plus 9 is 45. And the square root of 45 is 6.7. So I'm going to go from the center up 6.7 and down 6.7.
Just guess.
Okay, we can like, write it down and have it.
This one you kind of are just guessing on a little bit. Because it's 6.7, so you're just going to go up 6 and a little bit. This was already 6, so you're just going up 0.7 more than it already was. Which is going to make it, instead of being -1, 9 and -1, -3, it's going to be -1, 9.7 and -1, -3.7. Because you just took the vertices and put them 0.7 further away. So you're just adding a 0.7 onto the vertices, basically. Okay.
Alright, guys, we're done. Notes.